In this presentation we're going to look at Eulerian cycles and paths. An Eulerian cycle is a path through a graph that visits every edge exactly once before returning to the first vertex. For a graph to contain an Eulerian cycle, each vertex must have an even degree. That's quite important, so I'm just going to sort of highlight that or underline that, even degree. Each one must have an even degree. Just as a remark, there's some alternative names given in textbooks: Eulerian Tour and Eulerian Trail. So here we have a graph here, and we want to determine if there's an Eulerian cycle. First off, what we have to do is check the degree of each vertex to make sure it's an even number. So looking at vertex A, we see that degree is 2. Here at vertex C, degree is 4. At vertex B, it's also 4. At H, here it's 2, 2, 4, 2, and 2. So they are all even numbers, so we should be able to find an Eulerian cycle here. So we're going to pick as our starting point and finishing point A, and see if we can come up with an Eulerian cycle through this graph. So let's begin. I'm going to go from A to B. I'm going to make a little note of it here. A, B. Then I'll go to H. Then down to G. Now let's make a record of that. H and G. Now I'm going to go from G to F to E to C. Go around the perimeter. G, F, E, and C. Now I'm going to go back down to F. I could visit a vertex any number of times. It's just I can only use each edge once. So D and F. I'm going to go back up to B, then to C, and back to A. And that concludes our Eulerian cycle. So F, B, C, A. That's our Eulerian cycle. An Eulerian path is a path through a graph that visits every edge exactly once, but it's not necessary to return to the first vertex. For a graph to contain an Eulerian path, there must be exactly 0 or 2 odd vertices. Now, just to be clear, when I mean 0, an Eulerian cycle is a type of Eulerian path. But it's possible to be an Eulerian path without being an Eulerian cycle. For an Eulerian path that is not also an Eulerian cycle, there must be exactly 2 odd degree vertices. One of these must be the starting point of the path, the other must be the finishing point of the path. So here we have another graph here, and I've put in the degree of each vertex beside it in green, and we see that degree of A is 3 and degree of H is also 3. So these must be our starting points for our path. So let's begin and let's come up with a Eulerian path. So we must start with either A or H. Let's start with A, and we'll go down to B first, then down to C, and we'll go back up to A. Let's make a record of that. A, B, C, A. We'll go down to H, G, F, and D. So from D we'll go down to E and then B. And we'll go back to D then. So D, E, B, and D. Then we'll go back to C, and then finish up on H. And that is an Eulerian path. So we finished on two different vertices. We've started on A and we have finished on B. That's our starting point. That's our finishing point. And that concludes our presentation.